Hello guys, in this video I'm going to show you something cool. So you see this is aluminium foil. Theoretically you don't have to use aluminium foil. In fact, a cheaper alternative is if you were to use like aluminium cans. Let's say you drink a Coca-Cola can or Sprite. You just recycle the cans by scraping off using a sandpaper the labels, and then you can just use that as another form of aluminium. However, I can't be bothered with all that sandpaper, that scraping, so I'm just going to use aluminium foil instead. Not as cheap, but it also works. Now this is potassium hydroxide solution. You may also use sodium hydroxide, but for me it was easier to get potassium hydroxide because apparently it was next door for me. There was a potassium hydroxide store like nearby, but sodium hydroxide too far away. Alright, I'm gonna put this aluminium foil in potassium hydroxide. Something cool is gonna happen. Okay, I may have to zoom in. There's a lot of effervescence and it's heating up. I feel it's really hot. In case you're wondering what the effervescence is, it is of hydrogen gas. So in this reaction, the aluminium ions are reacting with potassium hydroxide to form potassium aluminate and hydrogen gas. Okay, I may have to fast forward this experiment. Fasting forward into the experiment, you can see that it's reacting very violently now. I never seen a reaction this violent. It's like bubbling like crazy. You know what? Let me collect some gas. Because why not? Look at, okay, nope. I can never touch this beaker while it's reacting. Oh my god, this is really hot. Okay, well, the aluminium is getting completely devoured and a lot of black residue is being released. Okay, the aluminium got completely devoured. You know what? Let me add a little bit more. Poof. And it's reacting very violently now. In case you're wondering why the reaction is so violent now, it's because there is heat. And with heat involved, the kinetic energy in molecular level is way higher, hence the chances of different atoms and molecules colliding increases substantially. Which is why the aluminium got devoured in seconds, and this insane amount of effervescence. The reaction is super fast now. More heat, more energy, faster reaction. Oh, I was trying to show you something cool. I was trying to collect the hydrogen gas so that if I were to light it on fire, it will burst and then the fire will extinguish, but didn't work. I suppose it's because I did not collect enough hydrogen gas. Oh god, my hands hurt. I can't help it but keep adding aluminium. It's so fun. When the solution is hot, it gives enough starting energy to kickstart the reaction. With enough energy, the reaction would happen really fast. Just now at the beginning of the video, you saw that the reaction was very slow. In case you're wondering why, it's because with less heat, less collision between atoms, and then reaction is slower. Aluminium is getting devoured so fast now. Alright, now, I can just keep adding more and more aluminium, but I guess I'll stop here. The purpose of this was not for me to get potassium aluminate. I just wanted to show you all a video. It's cool. Alright, I guess that is it. You can try this experiment at home. It's really fun. In case you're wondering where to get potassium hydroxide, you can get that in a form of caustic potash. You can buy it online for soap making. Thanks for watching.